All right, let's get going. So I'm going to just use the PowerPoint slides since these are just nicer. So hopefully that still looks okay on YouTube. But yeah, so let's do 5.4, systemic autoimmunity. So this is the idea where autoimmunity is reaching its full systemic scale in connective tissue disorders or conditions where self-recognition fails, not in just a single organ, but across the blood, synovium, skin, and serosae. That's the tissue that surrounds your organs. Okay, so this is body-wide. And I want you to think back to issues like sepsis, to issues like type 3 hypersensitivity, issues that were really, really hard to deal with because of how dispersed they were. And then layer autoimmunity on top of that, right? Not good, not good. That's why I have the forest fire here, just a spread of of positive feedback mechanisms resulting in a negative effect. All right. So, these connective tissues are pervasive. They're ubiquitous. They are everywhere. And especially if we're using the vascular pathways as a means of traveling, that's already where immunology begins. It begins with white blood cells. Blood cells are in the vascular system, so we're in their own stomping grounds already. All right, and the vasculature and synovium are frequent targets because they are both very immune active. I just said why vasculature is. Synovium, that is the joint space, which is inherently highly vascular, lined with macrophage-like synoviocytes. They already have a good presence of the immune system profile. So if things turn autoimmune, that's very bad for those regions. So let's go into two conditions that really exemplify this issue. First is SLE, systemic lupus erythematosus. So this is chronic relapsing multisystem autoimmune disease characterized by autoantibodies to nuclear antigens. Nuclear antigens, what do I mean by that? What do I mean? I mean DNA. That's tiny. I always do that on these videos. That's super tiny still. DNA. rRNA, so ribosomal RNA, and histones, and etc. That's not all inclusive. There's a bunch of nuclear antigens, but those give you an idea. The things within the nucleus. So anything in my nucleus. The DNA is what codes for absolutely everything inside of you. So having a response against that is not good at all. So we mount an immune response against anything that resembles anything in the nucleus. Etiology and predisposition. Yes, we have an HLA typing here. We have folks that might have a genetic issue that affects their complement pathway here. Again, a predisposition, not a guarantee. Just a susceptibility, if you will. Environmental, there's been UV exposure correlation and post-infection correlation if maybe a virus or bacteria affects with DNA clearance. Maybe that could cause this. Who knows? Hormonal, I have referenced a couple times. Yes, estrogen promotes B-cell survival as well as T-cell survival, actually. This isn't the whole story, though. In fact, a lot of lupus cases arise in like premenopausal or menopausal women, so that's when estrogen is decreasing. So what the heck's going on there? Not the whole story. Also, we have 2 X chromosomes in these individuals. So there's the theory that we're doubling up potentially on some immune receptors that are on the X chromosome. And then also I've seen some theories on a mother has a more robust immune system to protect an infant. So there may be some relationship there, but we're spitballing. I'm not going to lie. It is really interesting here because it's 9-1 in women. So there is something going on between those 3 pillars that I just talked about, but we don't know the whole story there. It has to do with all 3, though, we're thinking. All right, pathophysiology. So my B cells, they fail school. They're autoreactive and something didn't check. So now they're out floating around. That is step 1, autoreactivity against DNA antigens. This is step 2, though, and this doesn't really have to do with teaching. This is poor apoptosis clearance. So after cells die, after inflammation or infection, your cells are going to die. That's just what's going to happen. Remember, your neutrophils are not long for this world. They get to the site of infection, and especially if they do their net super move, the neutrophil extracellular trap, that uses their DNA. They're just exploding all over these pathogens, right? They're dying. So there's a lot of nuclear antigens floating around during sites of inflammation, but it's usually taken care of. You have a bunch of janitors. You have your macrophages. Your complement system helps organize removal of these things. If you don't get rid of this stuff, then you risk the immune system detecting it. And if we think about it, how often does your immune system really see your own DNA? That should be tucked away inside the nucleus. So there is a sense of, well, this stuff is usually sequestered and hidden away from the immune system, so it might look kind of foreign. Depending on what HLA combos, depending on your environment, it may look more foreign to other folks' immune systems, right? There's the variability there, but poor apoptosis clearance in any individual is not good. Once that stuff is done and used, we got to get rid of it, okay? Again, targeting DNA, histones, riboproteins, all that good stuff. Anything I find in a nucleus is now enemy of the state. Not good. So now I have antigen-antibody complexes absolutely everywhere that invade my vessels, my glomerulus, or my glomeruli, and my joints and skin. That should ring a bell to you. That sounds exactly like one of our hypersensitivities, and that being type 3. This is type 3 hypersensitivity big time. Great example of it. Okay, so this leads to tissue damage. If I have a bunch of antibody-antigen complexes depositing in my vessel wall, then I secrete inflammatory compounds. I secrete inflammatory cells because the antigen-antibody tag is telling my immune system, hey, remove this. This is a pathogen, but not in this case. The pathogen is my blood vessel wall. That's not good. So now my blood vessel wall is inflamed. Or the cells that filter the blood in my kidney, now those are inflamed. And that is one of the primary things we see in lupus, is lupus nephritis. So because of this hypersaturation of antibody-antigen complexes, my kidney function starts to decrease because of all of this inflammation. So we start to see downstream effects of that: poor pH balance, poor ion concentration, poor water concentration, all because my kidneys are now shutting down because the cells that do that function for us are dying because of this concentration going nuts. Okay, and then let's think about this further. Anything with IS, that means inflammation. Okay, so now I'm having cells in my kidney or in my blood vessel walls dying. A cell that is dying is releasing its innards out into the serum. One of the innards could be nuclear antigens, could be DNA, could be ribosomal proteins, could be histones. So now I'm releasing more nuclear debris, furthering the antigen supply. Again, antigen is kind of like quotation marks. It's my DNA. It shouldn't be a problem, but in this case it is. So I have more DNA in serum. Now I can form even more autoantibodies because it's just, further stimulating this process. I can't stress enough how detrimental the positive feedback loop is in all of these autoimmune cases, especially lupus. I said it in class, but I can't think of a better example of you attacking yourself than lupus. You are attacking your own DNA. Your DNA literally codes for yourself. What a terrible disease. Okay, let's press on. Immune failure. So again, deficient clearance of apoptotic cells. Really crucial here. Got to get rid of the things that are dead. Okay, just we don't sit next to corpses because of diseases they may carry. You don't want your plants sitting around dead plants. That rot will pass on. Same thing. If the cells are dying and just hanging out in my serum, that's going to lead to some bad stuff. Autoreactive B cells that see these apoptotic bodies and think, oh, that DNA, that's bad, even though they have that DNA within them. Poor Treg function, my peripheral T cells, my my peripheral T regulatory cells are lacking to some degree to not get rid of these autoreactive cells. And my complement system must be lacking as well. All right, treatment and management. Don't concern yourself too much with this because I know absolutely no pharmacology, but I did see this hydroxychloroquine pop up for combating systemic inflammation. I found that interesting. NSAIDs and corticosteroids, again, the inflammatory containment route, not stopping the pathophysiology here, but hopefully stopping the pain and swelling and inflammation that's associated. Immunosuppressants, telling your bad B cells to calm the hell down and stop binding my bloody DNA. And biologics, that is the whole thing with the drugs that end in AB, so sending some of those potentially helpful farmed antibodies into serum. All right. Epidemiology here. Also, I'm not going to ask you guys about this, but I think it's just cool to know. So 20 to 150 per 1,000. Okay, good numbers. 20 to 150 per 100,000 people. Again, strong female predominance. 9 to 1 is absolutely bonkers. I don't know if that's the biggest gender disparity in patho, but it's got to be up there. It's insane. Ethnic disparities, more common in Black, Hispanic, and Asian ethnicities, which is also very interesting. And we have 200K confirmed, maybe 1.5 on the probable side, and that could just be due to not getting care from an immunologist capable of diagnosing. So, yeah, that's the story there. I think that's just the big takeaway, just a wild discrepancy that we see. And now we can press on into RA, rheumatoid arthritis. So what is this? Angry joint is the too long didn't read version of this, but let's talk about it. So chronic systemic inflammatory autoimmune disease that targets the synovial joints, ultimately leading into a nasty thing called a pannus, combined with cartilage erosion and bone destruction. So all that sounds pretty not good. Let's go into it. So the etiology and predisposition. Again, select HLA alleles. I'm not having you guys remember, frickin' DRB3. That doesn't do me any good. Just noting that what does HLA code for? Well, that codes for MHC. Okay, let's that codes for MHC. MHC is antigen presenting, or the molecule that does that. Okay, so if the thing that codes for the molecule that presents my antigens is messed up, that can lead to an MHC that is more likely to present me, and that's not good. Environment, we have a big environmental trigger here, and that is smoking. So, periodontal infection leading to citrullation. Let me get into that in just a moment. Okay, we'll talk about this right here, but first, I want to stress, so again, the genetic component here is saying that some folks are more susceptible than others, right? It might be due to this MHC issue, and it could be due to some other gene loci that I'm not going to get into because that's a little bit out of my depth. So it increases your susceptibility, but it doesn't guarantee it. Smoking, especially if you have that risk, right, that will add to the risk because you're already susceptible, okay? I heard something wonderful in one of the talks I listened to. Genetics load the gun, environment pulls the trigger. Isn't that beautiful? I mean, write that down. It's awesome. I can't take credit for it, but that's so good. Okay, so smoking. That can, obviously your oral cavity, your lungs are not built to huff tobacco smoke. It's not built to huff air. That's what it's been part of evolution for. It has not been part of evolution for huffing smoke. So that could lead to decreasing the immune system in that area, leading to periodontal infection, as well as lower respiratory issues in the lungs. We talked about nuking the mucociliary escalator with too much nicotine. Okay, one of the potential issues here, and this can be a genetic component as well, but during those infection processes, we could lead to improper citrullation. Sounds very fancy. What does that mean? All right, if you want the textbook, it's deamination of arginine into citrulline. You're like, bro, why are you talking in Harry Potter spells? Calm down. Okay, deamination means remove, and amine. So we're taking off a nitrogen group from arginine, which is an amino acid, just a little protein chunk, and turning it into a different protein chunk. That's all I'm doing. Taking nitrogen off of arginine, and it makes it different. Okay? Taking a little puzzle piece away. This happens all the time. This is part of typical protein biology. We change amino acid structure all the dang time because that changes enzyme function and that changes product. Okay? So that's fine. It's all well and dandy. But when we have citrullination occurring where we don't normally have it, that can change the whole protein's structure. Right? Your proteins are made of a bunch of different amino acids. Oh my gosh, I didn't even notice. Let me go ahead and figure that and fix that. Should be CIT, C-I-T. Okay, so yeah, your proteins are made up of a bunch of amino acids, and the order and formation of those is very crucial. Changing just one can change the entire protein's structure. And especially when we're dealing at the cellular level with these very small peptide chunks that these immune cells are looking at, changing one can change the entire identity of that molecule. If the immune system was not ready to see something looking a little bit different, that's going to cause a response, especially if you're genetically predisposed. All right, hopefully that makes sense. Again, we see the hormonal blocking here, or differentiation here, 3-to-1, wild. And again, linking to periodontal diseases, things like gingivitis can lead to improper citrullination, as well as lower respiratory issues. So that's why smoking is such a trigger. Smoking not nukes, you still have immune system, but the function is very much decreased, leading to increased potential for infection of these routes. Okay. Ooh, a little bit messy, but let's go. Pathophysiology. This is the formation, or what's happening here is we form two autoantibodies that are bad news bears. So, antigen-antibody complexes floating around in serum, we just talked about that. That is type 3 hypersensitivity. No bueno. Again, we also just talked about improper citrullination, making these self-proteins looking strange. And we call a strange-looking new protein a neoantigen. So I have these slightly altered proteins now appearing in joint spaces. So now I'm going to create an antibody response to those proteins since they just look a little bit off. I present these citrullinated antigens to lymphocytes, and now we have inflammatory signals releasing from those local cells, bringing, pardon me, I got ahead of myself. Okay, the antigen-presenting cells bring those citrullinated antigens to lymphocytes. Now I get B cells and T cells recruited. And we'll talk about that in a sec. And now I have inflammatory signals in the area, which also recruits my innate cells. So all I'm saying is we have a lot of noise in this area. Back to the B cells. The B cells are going to see these improperly citrullinated peptides and create a response against it. They're like, well, I see citrulination in, I don't know, let's say my mitochondria, but I usually don't see it in the joints. So this looks foreign, this looks weird. We need to do something about this. So I make ACPAs, anti-citrullinated protein antibodies. ACPAs. So now I'm binding those tweaked proteins. And there's so many of them because, again, you are your own stimulus. They are everywhere. They're ubiquitous. So I have this response going on like buck wild. Another thing that can happen is rheumatoid factors get recruited in this case. This is when you secrete an antibody that tags the antibody. You're like, oh, good, that sounds super not confusing. Hopefully it's not too bad. So you have so many of these, eventually they need to get cleared. And you have a mechanism where your body tags serum IgG for deletion. Once it's done its job, we got to get rid of it somehow. But we have so many of these that we actually make way too many of the bodies that tag the bodies. So I have IgM antibodies that tag the butt of IgG. Okay, so think of the purple antibody as an ACPA, an anti-citrullinated protein antibody. And then think of the teal as a rheumatoid factor. That is what these are called, the IgM that binds IgG. So now I have, so this is binding to antigens, right? And this is now binding to the antibodies. So not only do I have, let's see, give me another color. So we usually have those antigen-antibody complexes, but now I have antigen-antibody-antibody complexes. So my serum is just like, oh my God, I am chock full of things that I don't need and can't handle. So hence the serum sickness, type 3 hypersensitivity tying in here. Completely and utterly overrun. Okay. On top of all that, we are recruiting so many inflammatory signals to this joint space, and it's messing up the proper homeostasis of the joint. And we're not going to get into all the signals here, but we have constant cartilage maintenance, constant bone maintenance, and now that is completely thrown out of whack. So we get cartilage erosion, we lose that cartilage disc, and that's there to shock absorb. That's there to aid in just movement of the area. Okay, so now that's gone. So now I got bone on bone. Great, doesn't sound comfortable. And I have inflammation. Great, doesn't sound comfortable. On top of all those inflammatory signals, they also mess up bone resorption and deposition signals. So I have bone breakdown of the area. So not only is it bone on bone, but it's bone on bone with breaking bone. Sounds and inflammation. Like, goodness gracious, very uncomfortable, I'm sure. So, yeah, that's the breakdown there. We have all of those inflammation, and that's furthering inflammation. So if I'm breaking bone and cartilage, that's also sending more AL signals. So it's just a compounding effect. All of that inflammation eventually makes the body think that we need more organic matter there. We need to send more blood to fix this, not knowing that, well, the things in my blood and my white blood cells are causing this bloody issue. So we have extra blood vessels come in and form. We get angiogenesis, and we kind of form not a tumor, but really close to a tumor. It's not carcinogenic in the way that the cell cycle's messed up, but we just have this mass of not needed, unregulated organic matter that overtakes this decaying joint space. So you just have a blob of crappy angiogenesis and inflammation that takes over your joint space. And that blob, that tumor-esque but not a tumor blob, is called a pannus. It's called a pannus. You can look up pictures. They're kind of gross. I'm not going to look up one. But that's the idea. So that's the ultimate formation there. And I hope you see how I got there. So we had an infection, we're smoking, and we had citrullination where we didn't need it. That makes the proteins look weird. So they look weird, they look foreign, we make antibodies against them. They're everywhere, so we make antibodies everywhere. We try to get rid of those everywhere antibodies, and we form the antigen antibody with the RF factors binding the ACPAs. So now we're just completely overrun. Our serum is hyper-concentrated with all of these inflammatory immune system stoking compounds, thus furthering inflammation, thus causing cartilage erosion, causing bone breakdown, causing pannus formation. Okay, so a couple steps there. I apologize. I'm not trying to make you guys make your head spin, but I think you can walk through. I think it's got a good flow chart to it. Okay, and again, not responsible, but I like tying things into the greater so what people are living with this kind of thing. 1.5 million adults in the U.S. That's not a small number. That's unfortunate. 3-to-1 female predominance. Again, estrogen, double X, something's going on. Typically presents 30 to 50-year-old, but not relegated to that. It can present at absolutely any age. Early detection and treatment is absolutely crucial. After 6 months, joint damage can become permanent. So going back to this drawing here, I want to save this cartilage as best I can. You know, that is what maintains fluid movement at a joint. I want to maintain my bones as best I can. I don't want to have them brittle and cracking. that will also make movement here horrible. So if we can get to it before we shear the articular cartilage disc, before we start shearing and cracking bone, and absolutely before a pannus forms, that will really, really help patient outcomes. So, yeah, so it's important to be aware of your body's signals, and if there's pain, what your body's trying to tell you. I'm not trying to have you guys WebMD yourselves, but this is definitely a case where early detection is very, very helpful. Okay. All right, cool. I hope the PowerPoint was fine. I just had everything already written here, and I didn't want to rewrite it again. If you have any questions, shoot me an email. We only have, what is that? This 5.4, 5.5, 5.6, and 5.7 is discussion day. So yippee-ki-yay, we are almost done. Have a wonderful day. Thank you for your time.